In this class, we're going to take a look at how you add and subtract algebraic fractions. So again, like all the other algebraic fraction operations, this is really equivalent to what you would do with number fractions, numerical fractions. So we're going to work these examples in a moment, but let's start by considering a number equivalent. So it's a little more difficult to add and subtract numerical or algebraic fractions than it is to multiply and divide them. And the main reason for that is when you multiply and divide, you don't need a common denominator, but to add and subtract you do need to make these denominators the same. So taking a numerical example, how do we go about making the denominator common? So this guy's got a denominator of 3, this has got a 5. That means that these are different types of fractions, so you can't just add them directly. If this was, for example, a 5, then we could just say, okay, we've got 2/5 plus 4/5. That's going to be 6/5, which would be an improper fraction, but still a fraction. But basically, you could just add them directly, but we don't have that option. So what we do, well, there's a couple of ways to think of it. You can either think of it as, well, the goal will be to multiply these guys together, because that guarantees that you get a common number. If you multiply 3 by 5 and 5 by 3, they both become 15s. So we're going to multiply those guys. How you do that is dependent on how you've maybe learned to do this, but you can either think of taking this fraction and multiplying top and bottom by 3, and taking this fraction and multiplying top and bottom by 5. Because if you multiply a fraction top and bottom by the same thing, you're not changing it, you're just writing it in an equivalent form. So that's one way to think of it, and that would give you here 12 on the top and 15 on the bottom. So it's the same fraction, just written in a different way, and it would give you 10 over here and 15 on the bottom, the denominator. Go ahead and add those and you get 22 over 15. So that's fine. The other way you can do it is to think of cross multiplying. So let me just write it down again. So 2/3 plus 4 over 5. So what we think about is just multiplying those together, which is what we did anyway, and then cross multiplying these numbers, okay? So it's effectively the same thing, it's just a different way of visualizing it. So 5 times 2 gives you 10, 3 times 5 gives you 15, 2 times 4 gives you 12, 3 times 5 gives you 15 again, so you've got the same thing either way. Personally, I prefer this method. I think this is the method we'll go with in these examples, but they are the same thing. It's literally just a case of like, where do I draw my arrows? Do I do them going that way, or do I do them just kind of going like more straight across? So taking that idea of making a common denominator, let's apply it to these guys. These are algebraic fractions. Notice that some of them have got numerical denominators. Some of them are algebraic and they get progressively more difficult. The technique doesn't really change. We're going to effectively just say, right, we need to make a common denominator by timesing these guys together, and we need to make the new numerators, because you can't change the denominators without equivalently changing the numerators, and we're going to make those new numerators by cross multiplying. So taking that idea, let's see what we get. So 5 times x gives you 5x for the top part of the first fraction. 5 times 3 gives you 15. So we're going to have a common denominator of 15 this time. 3 times 2x gives you a 6x on the top over 15. Got a common denominator, so we can just add them together. 5x plus 6x gives you 11x. And you just need one version of the 15 on the bottom. A really common mistake is to go ahead and add the 15s, but you don't need to do that, because if you think about it, here, this is saying we've got 10 15s, or 10 15ths plus 12 15ths. So that's going to be 22 15ths. It's not 22 30ths. So you're not adding these guys together. But that's a really common pitfall, so be careful not to do that one. Okay, so that's basically how we go about these. So we'll apply that same technique down here. So cross multiplying and timesing these together. I'll maybe just put the lines in again for this final one, and then we'll drop them over there. So common denominator comes from these two, multiplying together, and then you're cross multiplying to get the new numerators. So we'll start with this first fraction. So 5 times 4 gives you 20. X times 5 gives you 5x. Keep the sign the same. X times x gives you x squared. So slightly different format this time. 5 times x gives you 5x again. So unlike this one where we had an x term and an x term and we could merge them, this time we don't have two like terms. We've got a 20 and an x squared. You can't merge those guys together. So all that we can do is to write them as one numerator like that, 20 minus x squared over 5x. That's quite common. It's probably more common to see that than this. So expect to see that happening quite a lot, where you've just got to merge these two fractions together and write them in this more kind of compact form, but not being able to actually combine those terms. Okay, right, so let's take that same idea and apply it to these two. So they look a little uglier, but it's really just because we've got these kind of more complex terms, but the process is going to be identical. So we can see we're going to make a common denominator of 10 here. We're going to cross multiply. When we cross multiply, the 5 is going to times up to this guy here. The best way to do that is maybe just to use a bracket. So 5 times x plus 1. You can just go straight to multiplying, but remember you need to multiply the 5 to everything that's there. So it'll be 5x plus 5. Common practice is to use a bracket just to keep it all clear and keep it straight with what you're doing. 2 times 5 is 10, so the denominator will be 10. Same over here, so 2 multiplies up to the x plus 2 to give you 2x plus 2. Just going to use a bracket there again, over 10. And then we've got a common denominator, so we can merge them together. So 5, I'm just going to go ahead and multiply out my bracket at the same time. So 5x plus 5 plus 2x plus 4, all of that divided by 10. Just going to move this example down, it's starting to get in the way. So 3 over x plus 2 plus 4 over x plus 5. So there's only really one more step here, which is just to tidy up the top line by simplifying the like terms. I might squeeze that in over here actually. So 5x plus 2x is 7x, 5 plus 4 is 9, so 7x plus 9 over 10. That would be a very typical question in this topic, where you've got these kind of the terms that kind of look like this, cross multiplying, pulling things together, and then tidying up that top line. Okay, cool. Right, so let's take a look at this guy. Let me take the first line of working up to here just to save a little space. So we're just going to do the same thing. We're going to cross. Actually, let me just move that one up to make it a little clearer. So we're going to start here. So we've got 3 over x plus 2. The bigger challenge with this one is the fact that the numerators are numerical this time, therefore the denominators are algebraic. So a slightly more complex looking thing, but we're just going to do the same thing. I might just put the lines back in again. So these guys are going to multiply together to make your common denominator, which looks a little ugly, right? You're like, well, how do they multiply together? It's a lot easier to multiply a 2 and a 5. And we're going to cross multiply to get the numerators. So even though it looks more complicated, and it is more complicated, don't freak out and try to invent some new technique. It's the same technique. So just working through these. So the 3 is multiplying to the x plus 5. So we're going to get 3x plus 5. These two guys are multiplying together. The best way to do that is not to actually multiply them, but just to write them in a bracket beside each other, because two brackets beside each other, that means multiplying anyway. So rather than actually multiplying them out, just write them like that. That's a common way to do this. Multiplying the x plus 2 to the 4, so you're going to get 4 bracket x plus 2. So brackets are a really good practice in these questions, just to keep everything tidy. Okay, so we get that. A really common mistake at this point is to then cancel the brackets that you've just kind of created. Happens all the time. If you do that, unfortunately, you're just going to go back to where you started. So resist that temptation. You might find yourself doing that a little at first. What we're going to do instead is say, right, these are our common denominators. So we're just going to go ahead and merge the fractions with one version of that denominator. And then we're going to multiply we're going to combine these two, and I'm going to multiply them out at the same time. So 3 times x to give 3x, 3 times 5 to give 15, plus 4 times x to give 4x, and 4 times 2 to give 8. And then we would just finish that off by merging the like terms. So 3x plus 4x to give us 7x, and then 15 plus 8 to give us 23. And then just keeping the denominator in the brackets. You can multiply the brackets on the bottom line. There's no real benefit to doing that unless there was some particular reason why you had to do that. So the common practice is just to keep them in the brackets. So this kind of keeps everything neat. And that's basically how you do it. So we worked through quite a few different levels there, starting with the kind of numerical equivalent through to this fairly simple algebraic fraction with the numerical denominator, through to the more complicated looking expression, still with a numerical denominator. Probably the most difficult, but probably the most typical one as well, where you've got an algebraic denominator on both fractions in this kind of format here. So these are important. They come up a lot in a lot of different topics. So worth spending a bit of time getting comfortable with. So make sure that all of this makes sense. Don't overthink the technique. It's just this cross-multiplying idea, regardless of how complicated they get. But it's worth spending time getting experience of the different formats, just so that you're comfortable when you see those on an exam or a test. So you don't see it and you think, oh, I've never seen one like this before, and freak out. So gaining experience of a variety of question types is the best way to go. So yeah, definitely check out some practice questions on this topic.